An environmental triumph 400 million years in the making. This story is part of Fungi Week, a deep dive into the myriad ways mushrooms and fungi make the planet a healthier place for all its inhabitants. It is supported by UPIC Health. Each planting season, Claudia Bashian-Victoroff ventures out into Bole Woods, a 70-acre old-growth forest on the outskirts of Holden Forests Gardens in the Cleveland suburbs in search of fungi. But as she navigates the sugar maples, chestnut oaks, American beech, and western red cedar that tower overhead, she focuses not on the forest floor, but on what lies beneath. Kneeling beside a stand of maples, she clears away the leaf litter to reveal the topsoil and digs up the first few inches where the vast majority of soil microbes are active. Laced throughout, weaving an intricate microscopic web are the mycorrhizal fungishes after fungi that have spent 400 million years learning to live in symbiosis with plants, including the trees throughout Bole Woods, and at least 80% of all species on the planet. Bashian-Victoroff doesn't need much soil. A single spoonful can contain miles of fungal hyphae and filaments engaged in an ancient evolutionary exchange with the trees to which they've bonded. The fungi gather up water and nutrients and deliver them to the trees. In return, they receive carbohydrates developed through photosynthesis, which they fix into the soil as they grow. A pine root colonized by mycorrhizal fungi sends a network of white filaments into the surrounding soil in search of water and nutrients. Credit Mike Amaranthus. It's a prosperous cycle, and Bashian-Victoroff is among a growing global community of researchers and conservationists taking advantage of this relationship to restore forests and other degraded ecosystems. They goal promote the health of the soil beneath our feet and the plants it supports, sequester carbon, and make agriculture more sustainable. The soil in Bole Woods is part of a novel experiment in forest soil transfer that began when Cuyahoga County embarked on an effort to revive its declining tree canopy. In Cleveland, the portion of land covered by trees has fallen to 18% as a result of development and disease, with scientists suggesting 30% as a minimum target. As one of the county's partners on the project, Bashian-Victoroff, a fungal ecologist at Holden and a PhD student at Cleveland State University, has given some 600 new trees a boost by planting each of them with 50 grams of soil gathered from the nearby old-growth forest and teeming with fungi ready to lend a helping hand. By utilizing soil from Bole Woods, she's hoping to harness the power of locally adapted fungi to help the trees grow bigger and survive longer. Weighed down by negative news. Our Smart Bright weekly newsletter is the uplift you've been looking for. We're taking advantage of associations that have been happening between trees and fungi in our environment for thousands of years, Bashian-Victoroff says. Claudia Bashian-Victoroff takes preliminary size measurements of inoculated trees before planting them at restoration sites around Cuyahoga County. Credit Sarah Kiker. HFG. Holden first experimented with soil transfer nearly a decade ago, using the method to help bring forests back to land that had been used for years as a golf course. It proved successful, establishing healthy new fungal communities that Bashian-Victoroff thinks of as a great insurance policy for trees. Because mycorrhizal fungi are small and supple enough to penetrate soil more effectively than plant roots, they offer myriad protective benefits to their symbiotic partners, including support in times of nutrient or pathogen stress, drought tolerance, and shelter from toxic substances through the absorption of heavy metals. This winter, Bashian-Victoroff plans to analyze the urban trees planted with soil from Bole Woods to understand how their growth compares with control subjects, as well as their soil nutrient content and the fungal community's composition. Because mycorrhizal fungi rely on their plant counterparts just as much as plants rely on them, their populations are diminished in disrupted ecosystems, making restoration projects like the one in Cuyahoga County a vital, if underappreciated, act of fungal conservation. They are also an act of climate mitigation, considering that the carbon drawn down by mycorrhizae to develop their fungal networks is equivalent to more than 1/3 of annual global fossil fuel emissions. There's no better way to sequester carbon from the atmosphere and address the climate crisis than protecting and restoring our soils, says Evan Buckman, a consultant with the Soil Food Web School, which has taught farmers in more than 100 countries how to reintroduce fungi to promote soil health. Mycorrhizal fungi can be an important part of a broader suite of climate solutions, says Anne Polyakov, a fungal conservation and restoration scientist with the Society for the Protection of Underground Networks, or SPUN, which recently used machine learning to map the planet's mycorrhizal networks in an effort to promote conservation. These benefits, including enhancing the effectiveness of reforestation efforts like the one Bashian-Victoroff is undertaking in Cleveland, make mycorrhizal fungi a critical part of healthy ecosystems, Polyakov says. They are often the quiet, invisible drivers of whether restoration succeeds or struggles, she says, knitting together soil and carrying out their critical resource exchange. At Rhizocore Technologies, a nascent UK company focused on woodland regeneration. All of that restorative potential gets bound up in small pellets the size of a sugar cube packed full of locally adapted soil fungi. The company provides them to its dozens of partners, landowners, conservation, non-profits and forestry agencies to be planted with saplings as a subterranean support system. In just a few short years, Rhizocore has treated more than 600,000 trees across the UK. Europe and Australia reporting improved survival and growth rates in its field trials. Sitka spruce, a key timber species in the UK, has shown a 20% increase in both survival and growth rates, with the pellets Rhizocore says. In the effort to rebuild damaged ecosystems, it's got to start from the soils upwards, says Petra Guide, a Rhizocore data scientist at potato plants from a field.